Alright, in this video we're going to go through a chi-squared test of independence from beginning to end. And this is another experiment. Some of you may have seen it. If you took Stat 1 with me, I apologize, but this is one of my favorite examples. This was a randomized experiment to look at the effectiveness of acupuncture in treating chronic lower back pain. So there were over 1,000 patients that were randomly assigned to one of 3 treatment groups. So there was real acupuncture, traditional Chinese medicine, sham acupuncture, which was a placebo, and non-acupuncture therapy. So I'll let you think about what sham acupuncture was, how you would do a placebo in this case. Basically, you're just poking people with needles in no particular places, still sterile, still safe, but not real acupuncture. So that's our explanatory variable, right? We've got these 3 treatment groups. Okay, so our explanatory variable is categorical, and then our response variable is whether there was a substantial reduction in pain. So here we're also treating the pain reduction as a categorical response. So everything in this chapter is categorical responses. Okay, so our null hypothesis would be that the probability of improvement, and this is the long run probability, so we're going to write it as pi, not p. The long run probability of improvement if you get real acupuncture is the same as if you get sham acupuncture, is the same as if you get non-acupuncture therapy. So notice non-acupuncture therapy, that's not no treatment at all. It's just drugs and physical therapy and other types of therapy. Okay, so that's the null hypothesis. And then the alternative would be that at least one of those probabilities is different from the other. So maybe not surprising based on how we've done this for an F test and other times that we've tested multiple parameters at once. So why do this? Why conduct a test with multiple parameters at once instead of just doing multiple tests that compare 2 treatments at a time? So remember, we have this problem with multiple tests, right? Multiple tests, you're more likely to get a false positive. More likely to get a false positive. And the reason for that is because when we talk about our alpha level as the probability of type 1 error, we're talking about one test. Right? But if you do multiple tests and you think of the probability of getting at least one type 1 error, it starts to blow up on you, right? The probability that you make at least one false positive is actually going to be higher than alpha. So what we want to do is we want to do one test, test everything at once, and that's going to keep our type 1 error rate under control. Okay, so let's start off by looking at a mosaic plot. So we can see from the width of the bars that the sample sizes were all about the same. And then we can look and see that there does seem to be some difference, at least in the sample, of improvement, right? Both real and sham seem to be more likely to get better than the non-acupuncture group. Okay, so the fact that we have different probability of success in each group so the fact that the proportion of improvement who improved is not the same in all 3 groups. right? We didn't get the same thing each time. The proportion who improved is not the same in all three groups. So that means that there is an association in the sample, right? We can tell that the proportions are not the same in each group for this sample of 1,000 people, but we don't know yet whether that would persist in the long run. Is acupuncture actually increasing the probability of improvement? So we're going to do a chi-squared test for this. So to check my validity conditions, I have to look at the expected counts. And here I just let R calculate them for me. I could have done the formula row total times column total divided by overall total, but I just took a shortcut here. So I can see that my smallest expected count here is 153.9. So plenty big enough. We want it to be at least 10, and it's bigger than 10. And so my validity conditions are met, right? I can do a theory-based chi-squared test here. Okay, so I'm going to keep using the output. I've got a chi-square statistic. So my chi-square statistic is 38.054. You can see the degrees of freedom here is 2. If you want to show how to calculate it, you had 3 rows, so 3 minus 1, 2 columns, 2 minus 1. So that gives you the 2 degrees of freedom. And my p-value is essentially 0. So that small p-value means that I have strong evidence to conclude that there is an association between the type of treatment, so what kind of acupuncture you got, or whether you got non-acupuncture treatment, strong association between the type of treatment and improvement. So whether or not somebody improved. But remember, by the way that we've written our alternative, we're sort of limited in our conclusion, right? The only thing we're really saying is that at least one treatment is different from the others, right? So that may not really be satisfying because we want to know which treatment is better, right? Does it matter whether you have real acupuncture or sham acupuncture?